Rational functions, if you guys remember what a rational number is, anything that can be written as a fraction. So that's what a rational function is, okay? The equation with the fraction, where you have a variable on the denominator at least. So if I give you a table, a graph, or equation, you should be able to find the end behavior, okay, and the domain. We ready? Okay. So first off, a rational function R, that says R, is analytically represented as a ratio of two polynomials. And we just did polynomials, right? So you have a polynomial on top, you have a polynomial in the denominator. Polynomial can be simple as like 3x, okay? And the numerator can be as simple as 3. If you have a 3 on the bottom, then no, okay? That just has to be a variable in the bottom. But remember, what does that say? The denominator cannot equal to 0. Why can't the denominator equal to 0? It's undefined. Now, actually, calculus you learn, you guys, we've always said it's what? Undefined. It's not actually. There's an actual answer for that. Anybody know what it is? This was on Mr. Avila's first quiz. If you're taking calculus next year. So if you're taking calculus next year, you put that on his first quiz. So, okay, it's infinity. And when you divide something by 0, it could actually be positive or negative infinity, okay? Depending on what you're doing there. So you can kind of prove it. What happens, like, if I divide by a small number? What's 1 divided by a half? Anybody know what 1 divided by a half is? Huh? 2, right? Don't you multiply by the reciprocal? So 1 divided by a half is the same as 1 multiplied by what? 2, right? So let's make the fraction smaller. What's 1 divided by 1/10? Isn't that even smaller? What's that going to be? 10. What's 1 divided by 100? 100. What's 1 divided 1 over 1,000? So what's happening as this number gets closer and closer to 0? It's getting bigger and bigger and bigger and bigger, right? 1 divided, I don't even know how many zeros I have there. 1, 2, 3, 1, 2. 1 divided by 100 million is going to be what? 100 million. So it's getting big, right? So as this number gets really close to 0, my other number, when I divide, gets close to infinity. Okay? Okay. That's why. Not undefined. All right. So let's look at this one here. So when I look at domain now, when we had polynomials, I did not have to worry about the domain. I can put any number I want into a polynomial. X squared times x plus 3. I can put any x I want and get an output, right? But with rational functions, we got to be careful. What can't we have? We can't have 0 in the denominator, okay? So we have to consider domain restrictions when we graph these or solve these. So what you have to, now, numerator doesn't ever matter. I can put any number in the numerator I want and get an output, right? Now we got to be careful down here, right? What can't I have? The denominator cannot equal to 0, right? So we have to find what value of x will make my denominator equal to 0. So I like to, so what is that going to be? 3x plus 12 equals, cannot equal to what? 0? 3x minus 12 cannot equal to what? Negative 12, divide by 3. X cannot equal to negative 4. Okay. Now, so what is my domain? You can write it in two different ways. So my domain, you can write it with inequalities, or you can write it in interval notation. Now, usually they don't care unless they tell you what to write it in, okay? But what does this mean? I can have every single number out there except for what? -4, right? So if I graph this like on a number line, isn't that every number except for -4? I have a hole, right? So you can write it this way. X is less than -4 or X is greater than -4. That gives you the whole. And the other way, interval notation is from what? -infinity to -4 parentheses joined with -4 to infinity. And so I don't really care, but just if it says interval, you have to write interval, okay? Now, this is the graph of that one. So what do I get in my graph when I have this? When I say X can't equal to -4, what shows up in my graph when I say, what is this called? Does anybody know what it is in my graph? When I say X can't equal to -4? Y'all graphed this last year. Is it, what kind of asymptote? Horizontal? Which one is this? X, right? So which one is X? This one? So what is that? 1, 2, 3, isn't that right here? So you can't have a horizontal. It'd go through every X then, wouldn't it? So it's a what? Our vertical asymptote is where X equals -4, right? Vertical asymptotes affect your domain. Now, just for fun, anybody else see another asymptote here? Do we remember what this one is? It's not horizontal would go this way, right? Does that one go that way? What does this one go? Diagonally. If you're in my class last year, I made you do extra problems on your own on this. What is this called? That's not a horizontal asymptote. That is not a horizontal line. Do we remember what that's called? If you're Miss Kim's class, I know she taught it. Mr. Avila's probably taught it. Do we remember what that's called when it's diagonal like that? What kind of asymptote? No? What do we call it diagonal? There's two words for it. One starts with the S and the other one starts with the O. Huh? Slant asymptote. And what, does anybody remember what the O starts with? Huh? No, that's not. What kind of? They call shapes like this when the shapes slant. You should have learned that word in geometry. Oblique. I told you guys in my class, you guys were supposed to study that on your own. Okay. You were in my class last year, you were supposed to do that. I gave you an assignment on Google Classroom. Okay, slant or what? Oblique. Okay, it's slanted. We are going to do those this year. Okay. Okay. Here we go. How about this one here? So what is my domain? So what do when I have a rational function, my domain, the only thing I care about is what? When the denominator is equal to 0, right? Because the numerator can equal to 0. 0 can be divided by anything I want. Okay, so what do we have here? X squared minus 2x minus 24 cannot equal to what? 0? If I factor this, x minus 6 times x plus 2 cannot equal to 0. So x cannot equal to 6. X cannot equal to -2. So how do I write that as my domain? So what is this? -2 and 6 is like having a whole, I can have every number except for what? -2 and 6, right? So how do I write that in my notation? Okay. Oh, I don't know, it's 4. Because I was doing the 2, sorry, thank you. Just fix it. Sorry. I was making them add up to 2 and then I wrote the 2. All right, that works better, right? Okay. So now, how do I write this in inequality? So, do you guys see how there's 1, 2, 3 pieces there? Because there's you need to have 3 parts, okay? So what's this first part here? Every number is what? Less than -4, right? So in inequality, you write x is less than -4. Or I'm gonna be like, what else do we have? X is in between what? -4 and 6. -4 less than x less than 6. Or this piece here is what? Anything bigger than 6, right? X is greater than 6. Okay. If I ask you to write it in interval notation, okay. So what is this? On this side is what? -infinity to -4. Therefore must have parentheses. Joined with what? -4 to 6. Joined with 6 to infinity. Okay. Okay. When we have a graph, domain is what? Your x values, right? So it's not your y value. So I'm going from left to right. So if I follow the graph, if I go on my x-axis here, okay, what values can't x be? So I'm going like this, like I'm following the graph that way, right? Well, what do I have right here? An asymptote, correct? So that means x can't equal to that number. So what is that number here? What is that? -2? So x can't equal to what? -2? Well, that's the equation. So let me write this better. That's the asymptote x equals -2. And what's this one? 1, 2, 3, 4, 5. That's the asymptote. So what does that mean? I can't have those two values. I can have every other value of x because it goes forever left, it goes forever right, and it seems to all exist inside here. Okay. So what do we have? Everything except for -2 and 5. So we have what? I'm going to use interval on this one. There's 3 pieces. Can you see it when I write it in the pink back there? Yeah. So if you have an equation or graph, you should be able to find the domain. Pretty easy, okay? Okay. You guys go ahead and do those 3. What time do we get up? 18? And read the directions. It says use interval. Don't forget to take out the GCF, or that becomes almost impossible to factor. Okay. You can do it, but it takes longer. We okay with these? Now realize, okay, that this rule only applies to what rational. So you guys think when people ask you for domain for different functions, is it this one in my other class here? If I have a square root function, this is just to review some of our ones you did last year. Right? This has a restricted domain too. Okay, what can I not take the square root of when we're trying to graph it? What kind of numbers can't I take the square root of? Huh? When we take square root of negative numbers, what do we get? Imaginary, right? And if we're graphing it, that's not going to work, right? So this, if you get a square root function, you can't, it's not equal to 0. What do I have to say? X plus 3 has to be greater than or equal to 0. So if you graph this, my domain is what? X is greater than or equal to negative. If you remember the graph of this one, that negative 3 was that one. Okay. Now, how about if I do this? I put 1 under above it. Now this can't be negative, but it also can't be what? 0. So now we change it to that. Okay. So it just depends on the type. And remember when you have log? Okay. What can't we take the log of? Remember we can't take the log of? Negative numbers. Can we take the log of negative numbers? Some of us need to go back and review some stuff. All right, let's go ahead. Here we go. Huh? M behavior. We are going to use limit notation. So all rational functions, the other ones, polynomials, either positive or negative infinity. Okay. Rational functions can be anything. Okay. So this one, remember I showed you guys earlier? This is shooting, like there's an asymptote here, right? So this one's shooting what? It's going down, down, down. It's just going down slowly, right? And what's happening on this side? I can't do it. That side's going up, but slowly. Okay, so what is our end behavior going to be? On the left side, limit as x decreases without bound, goes towards the negative infinity of my function. What is happening on my left end here? It's going down, 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 which is what? Negative infinity. Okay. And what is happening on my right end? Limit as f of x, as x increases without bound of my function. It's going what? Up, 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 up. But it's just slowly. So what is that going to be? Okay. Okay. So rational functions can go to positive or negative infinity. Okay. They can also go to a number. Okay. You guys see, I'm going to go back here. You see this graph right here? Oh, okay. You see this graph right here? It's going left, but is it going towards infinity? All right, so we'll talk about those in a minute. So let's go ahead. How about if I just have an equation? Oh, I left my thumb. Oh, it worked. Did you make them?
Yes.
A bunch of them? You happy now?
Yeah, and you know what's crazy?
Huh.
So I had to go down the drop down menu and change it because you had it on your maker.
Oh yeah, you have to change the thing. Oh, you didn't know that? I'm sorry. I was like, because I used that machine before.
I was like,
Oh, sorry, I just, okay. Now, if you have an equation, let's say we don't have a graphing calculator, we could actually graph this and figure it out, right? We don't have a graphing calculator, and that's very hard to see what's happening, correct? So what we're gonna do is we're gonna just plug in numbers. So this side, what's happening here as x increases without bound, right? So what are they doing to your x values? They're making it bigger and bigger and bigger, right? So I want you guys to put these values in your calculator. So now let me tell you one thing here. When you are typing it in, okay, be careful as you type it. Let me see if you guys will notice it here. Okay. What was the equation? I already forgot. 4. So watch if I just type in 4 times 10. What is it? -1. And I hit divide. Look up here before you guys do it. Is that what I want there? No. So if you have more than one operation going on in the numerator, you have to put the whole numerator in parentheses. So put parentheses 4 times 10, what is it? -1. And then then you close the parentheses. So you're telling the calculator, because there's more than one thing going on in there, that's the whole numerator. And now hit divide. Now does it draw the big fraction bar for you? Okay, so be careful as you're doing that. Okay, what goes on the bottom? 10 squared minus 2 times 10 minus 24. We all get 0.696. Okay. Okay, do 100, 1,000, and what is it? 10,000. See what's happening to your output values as x gets bigger and bigger and bigger. Do the copy and paste. Did anybody do the 10,000 yet? What kind of notation is that in your calculator? scientific, so realize it does, okay, it's too much. So make sure you move that decimal over 4 places if you, it gets, you got it? My answers are, make sure you know how to get them. So what's happening to my output values? As X is increasing, right? Increasing. What is happening to my output values? They're getting what? Smaller, but are they going towards negative infinity? What does it look like they're going towards? Getting 0.696, 0.041, 0.004, 0.00, I don't know how many O's there are, right? What's happening to that number? What's it getting really, really close to? 0. So limit as X increases without bound of what function is this? G of X? Where is it going towards? 0. Okay. Now try the negative side. What's happening on the negative side? So you do 2 of them, have your partner do 2 of them. You can just copy the equations above and paste them. If you want, up to you, whatever's quicker for you. Did you pick the small numbers and give her the big numbers?
I gave her this.
I thought you, oh, okay, I thought you said I'll do negative 10. So do it with your partner, do 2 and 2. I only did 2 of them. I was too lazy to do the other 2. You guys can figure out the other 2. Aaron, what you get for 1,000? It's negative, right? Or is it positive? Who did 1,000? Anybody else do 1,000? What do we get for 1,000, Tony? Was it negative or positive? Okay. What do you mean? Let me put it in. I didn't do it earlier. Where's my, I don't even have a calculator. There's the first 2 negatives, right? Positive? Okay, hold on, let me check. Can I ask you something? Are you guys putting negative 10,000 squared in parentheses? You have to put the square in parentheses. When you, if you do this, what am I asking you to square? Negative 1,000. If you put this in your calculator, are you squaring negative 1,000? You're only squaring 1,000. This mathematically is not what it's being asked to do. This is what it's being asked to do. You have to put negative 1,000 in parentheses when you're squaring. Okay? These are 2 different answers. I'm gonna do negative 100. That's negative 10,000. You square negative 100 like this, it's positive. What are you squaring? Are you squaring 1,000 or are you squaring negative 1,000? So you need to square the negative. It has to be in the parentheses. These 2 are, if you do this, it's wrong. What parentheses? I didn't check the squared minus 2 times, what is it, negative 1,000, 10,000? What is this, minus 24? I got negative, it's negative. Okay, what's happening to this number? Isn't it also getting close to 0, but just on the negative side, right? So what do I write on this side? Limit as x goes towards what? Negative infinity of my function g of x is equal to what? 0. Isn't this getting close to 0? Okay, hold on. So if both of these go to the same number, that is actually your horizontal asymptote. Okay, you have a horizontal asymptote at y equals 0. Okay, you guys can finish the notes. I think you should be okay. You can finish the notes, and there's a small worksheet on Google Classroom. Yeah. Hold on, let me end this so it can